All right, which of the following is the horizontal asymptote of that graph? To find the horizontal asymptote, what you're looking at are the exponents here of the highest degree. So this is x to the second and x to the second. Since those are the same, we are going to steal the coefficients here. So this is 4 over 1. So y equals 4 over 1 is the horizontal asymptote. So it's y equals 4. They will always put the tricky correct answers for other things on here. Like, for example, this is one of the two -5 and +5, or the vertical asymptotes. And you notice they put that there for an answer, but you need to recognize that they're looking for a horizontal asymptote here. Next problem here. Solve these equations. So what we're looking for is a least common denominator. So this x squared minus 1, you might want to factor out to recognize that that's going to be x plus 1. X minus 1. So that is our least common denominator. Because the first term, our first term has an x minus 1. So we have a 3x over an x minus 1, and this needs an x plus 1 in the denominator. And what you do to the bottom, you have to do to the top. And we already have that x plus 1, x minus 1 in the bottom. And then we have a 2 that needs both the x plus 1 and the x minus 1. Since all the denominators are the same, you drop them essentially, and you have 3x times x plus 1 equaling 12 plus 2 times x plus 1 times x minus 1. And actually this is a case where it's easier to multiply those out and get your x squared minus 1, because we have to distribute. Now, watch your order of operations. You distribute first, then you combine your like terms. So we have 3x squared plus 3x equaling 12 plus 2x squared minus 2. Bring this over to the other side, we subtract it. And we have x squared. We have our 3x. And then this 12 and negative 2 is going to give you a positive 10 on the right side. And so we're going to subtract 10 to bring it to the left side. When you factor this and solve, I put this down a little bit. When we factor this and solve, we have an x plus 5 and an x minus 2. We're looking at the factors of negative 10 that add up to positive 3. So x is going to be equal to negative 5, and x is going to be equal to 2. And what you need to do at this point when you think you're done is check to see if either the 2 or the negative 5 is going to make this denominator 0. And the only thing that are going to make these denominators 0 are 1 and negative 1. So these solutions, there are 2 of them, and they both work. Excuse me. So x equals negative 5 and positive 2 are the 2 solutions. Again, notice still no calculator on this one. Not that I would attempt to do this by calculator. But before we find our common denominator, let's factor. Factors of 8 that add up to negative 6 are x minus 4 and x plus 2. So this one has an x... I'm sorry. That's not correct. It's x minus 4 times x minus 2. And what's nice about this is usually it gives you a hint over there on the left side, which is where I quickly caught my error. This has an x minus 2. This has an x minus 4. So this needs... This has an x minus 2. It needs an x plus x minus 4. So what we do to the bottom, we do to the top. The 3x over x minus 4 needs an x minus 2. And this 32 minus 2x already has what we need, which is the x minus 4 and the x minus 2. Denominators are all the same, so you just focus on the numerators now. X times x minus 4 plus 3x times x minus 2 equals 32 minus 2x. Go ahead and distribute. And we have x squared minus 4x plus 3x squared minus 6x, sorry about that, equaling 32 minus 2x. Add, that's not crossed out. X squared and the 3x squared is a 4x squared. the negative 4x and the negative 6x is negative 10x equals 32 minus 2x. Go ahead and bring the x's over to the left and the constant over, so we're going to add the 2x to bring it over. We're going to subtract the 32 to bring it over. And finally, on the left side, we have 4x squared. Negative 10 plus 2 is negative 8x minus 32 equaling 0. GCF, I do not want to factor this without pulling a GCF out first, if at all possible, which it is. Pull a 4 out, and we're left with x squared minus 2x minus 8. Much easier to factor, because this is x minus 4 times x plus 2. And then you take the x minus 4 and set it equals 0, and the x plus 2 and set it equals 0. And we have two solutions that we think might work. But before we stop and say, whoop, that's it, final answer, we need to check to see if either one is an extraneous solution that's going to make our denominator 0. So as we're looking here, a positive 2 or a positive 4 will both make that denominator 0, and therefore makes an extraneous solution. So the positive 4 does not work. That's extraneous. And the final solution is just x equals negative 2. On the next page, which of the following is false? Well, again, this is no calculator, so you have to have an idea about what ln of x looks like. It's a log function. It would have a vertical asymptote at x equals 0. So there's your asymptote. And it should go through 0, 1 here. Sorry, not 0, 1, through 1, 0. So it should look something like this. And it's going to approach that asymptote but never hit it. So the domain is all positive real numbers. Yes, because these are the negative real numbers and it doesn't exist over there. So all positive real numbers, so this is true. Second one, ln of x increases without bound, which means it increases always. So as you go from left to right, this is always going up. So this is also true. E to the x and e to the negative x. Well, we need to know what those look like. Kind of in our mind, we need to know what that is. So e to the x is exponential growth. This is e to the x. And e to the negative x would be the decay of that, e to the negative x. So graph of e to the negative x is graph of e of x reflected over the y-axis. That's also true. Finally, g of x equals e to the x has a range of all real numbers. Well, this has a horizontal asymptote here. So it's not all real numbers. It's all the y values greater than 0. So is this true? No, this is false. So the letter D is the false statement. Now we're getting into a whole lot of problems on logs. This is a problem where we are rewriting. So division, remember, becomes subtraction. So log based 5 of 5 minus, because you have division, x to the third, remember that exponent becomes the coefficient, goes out in front, 3 log based 5 of x. And that answer choice isn't there because we can evaluate this. 5 to what power, 5 to the question mark, 5 to what power equals 5? Well, that's going to be equal to 1. So this is 1. Log base 5 of 5 is 1 minus 3 log base 5 of x, which is answer choice B. Next one, again, with subtraction, we've got an exponent, we've got a square root, so there's a whole lot of stuff going on here. So the first one is going to become 2 log of y minus, because you have your division, and then this is really x to the 1/2 power. That's what square root is. So it kind of gets treated the same way that y to the second is. The 1/2 goes out in front. Log of x. So this is the condensed version up here, and this is the expanded version, which is letter B. Okay, now this is expanded version. We want to condense. So this is going to become the exponent. The 3 becomes the exponent, so it's ln of x to the third power. Multiplication, addition becomes multiplication, so times z. And then it's going to be divided by ln of y. So it's divided by, minus ln of y becomes divided by y. So that is going to be answer choice C. And then you need your parentheses here. Okay, which is equivalent to log of 20 divided by log of 2. Please do not divide those, as is. This is really asking you to use what's called the change of base formula, where you have log, if you have log base a of b, this is equal to log of b divided by log of a. So if we have log of 20 divided by log of 2, this is really log base 2 of 20, which is answer choice C. 13 and 14. Number 12 and 13. This is a calculator problem. You notice no calculator has gone away, and so the expectation is that you use the calculator. And the very new calculators, the newest, you can put that in directly. Everybody else is going to have to use a change of base and put it in as log of 6904 divided by log of 2, so use the log button. And that's going to give you 4.543. And it says, pay attention to the directions. On this entire exam review, finally, second semester, they got this consistent. Everything's rounded to 3 decimal places. We have to take off when you're not rounding correctly. 13. Again, this is going to be log using the change of base formula if you don't have the newest of the new calculators. 0.0123 divided by log of 4. And round 2, this is negative 3.173, round to the third decimal place. 14. We're reflecting over the x-axis. So if we're reflecting it, g of x is going to be f of x equals 3 to the x. So we've got 3 to the x reflected over the x-axis. So reflect over the x-axis, it's going to put a negative out in front, because that's going to reflect, and it's going to be opposite y values, so the negative goes out in front. And 5 units to the left. To go to the left, we're going to be in the exponent x plus 5. If we wanted to move to the right, it would be x minus 5. If you wanted to move up or down, it would be over here on the same line as that base that we like plus 2 would go up 2, minus 3 would go down 3. If we had a negative in front of that x there, that would reflect over the y-axis. So they're not going to ask you probably this exact question. They could ask about reflecting over y. They could shift up and down, or they could do something very similar to this. So just be prepared. We are reflecting about the y-axis. So now g of x, reflecting over the y-axis is going to make this 9 to the, what's going on with this thing? 9 to the power of negative x. That reflects over the y-axis. Stretched vertically by a factor of 7 is going to multiply this times 7. And don't multiply those. That just means that the 1 that was not showing up there before is now 1 times 7, or 7.